13,700,000,000 years ago, the universe we observe today was much smaller than a grain of sand. In the biggest explosion of all time, lasting just a fraction of a second, the universe expanded into a bubble billions of kilometers wide. In this dense whirlpool of incredibly hot matter, elementary particles collided so often and so violently that atoms had no chance of forming. After expanding and cooling down for 300,000 years, the temperature of our universe was now only a few thousand degrees. In these less extreme conditions, electrons at last settled into their orbits around the atomic nuclei. Free from constant interaction with electrons, light particles or photons were able to escape into space, and so the universe became transparent, and the original photons sped towards infinity, the last witnesses of the turbulent very first instance of creation. There was also a mysterious substance, dark and invisible, that was to play a central role in this process. Because of its mass, this substance brought a new phenomenon into play: gravity. The mix of matter and dark matter condensed into increasingly dense filaments made up of millions of galaxies isolated or grouped into clusters. Here is our galaxy, the Milky Way. 200 billion stars, 200 billion hydrogen bombs, whose internal gravity prevents them from exploding into space. But how did this gaseous universe of hydrogen and helium turn into solid planets like the Earth? In a process that repeats itself infinitely, massive stars burn their fuel and produce heavier residues like oxygen, carbon, and iron. With diameters many times greater than the distance between the Earth and the Sun, such stars burn for millions of years before running out of fuel. When this happens, their cores collapse in just a few seconds. The outer mantles of these supernovas are flung into space. But stars do not die in vain. They seed the universe with new elements that, like this carbon atom, end up as part of the gas and dust clouds of a nebula. Nebulas are galactic nurseries, constantly producing new stars. In some places where the temperature isn't too high, these molecular clouds, consisting mostly of hydrogen, contract under the effect of gravitation. Over the next few million years, the cloud evolves into an incandescent ball with a small mass, like our Sun. Complex atoms ejected by supernovas amass around the young star. This stellar belt of mixed elements finally condenses into planets as different as Jupiter, Saturn, and Earth. The Earth, our planet, was formed 4,600,000,000 years ago, bombarded by meteorites. and shaken by earthquakes. It was surrounded by an atmosphere rich in water vapor and carbon dioxide. As the temperature gradually cooled, a downpour lasting several million years began. Our blue planet owes its color to the bacteria and algae that produce the oxygen in its precious atmosphere. And so, the adventure of life can begin. Today, when you watch night sweeping across the planet, hundreds of luminous specks light up. This may not add up to much on the scale of the universe and its brilliant suns, but it's yet another stage in the journey of matter. Mankind in darkness, forever striving towards the light.